All right, now we're going to have a look at these practice problems here. So we're going to start off with something like this. In this case, QR is going to have these endpoints here, -3, 9, and 9, -9. We want to determine the location point S on QR such that this is true. Now again, you can use the formulas here, but it's often a good idea, especially if the formula is kind of complex like that. Just really have a look at this here. So let's have a look. Okay, so it's going to be -3, 9 here. So I'm going to try to sketch this and make it a little bit more accurate. So -3, 9 is going to be somewhere around here. So this is Q, and then, oh boy, -9. So it's going to be something like this here. There. And this is going to be -3, 9. All right, so we're going to do this one step at a time here. So there are two ratios, 1 to 2 and 5 to 7 here. Let's focus on the 1 to 2 ratio first, okay? Now, the best way to think about this, again, we saw that we can look at the big triangle here. Whether it's up or down, doesn't really matter here. We can look at this triangle here. Let me call this point here T. Now, we know that the legs of this triangle here, we go from -3 to 9, that's a total of 12 units here. And we go from T to R, that's a total of 18 units here. So if QS to SR is in a 1 to 2 ratio here, so I'm going to go ahead and sketch that out. If QS to SR is a 1 to 2 ratio here, that means we're going to divide these also into a 1 to 2 ratio as well. So that means we're going to have to just do something like this here. A 1 to 2 ratio here, right? A 1 to 2 ratio for 12. That means we're going to divide 12 into 3 parts. It's going to be 4 here. So we're going to do something like this and something like this here, right? And then we can also divide this into a 1 to 2 ratio. So again, we're going to divide into 3 parts. I'm sorry, I said 3 parts. I said 4 parts before. It should be 3 parts. So we can do this here, something like this. So we can do our thing like so. Now this is a quarter. This is going to be 1/3 of 12, so that's going to be 4 here. And this is going to be 1/3 of 18, so that's going to be 6 here. So we're going to go from Q -3, 9 down 4 and 6 here. So that means it's going to be, so now because we're sloping down here, so we're actually going to go here. So it's going to be -3 plus 4, comma 9 minus 6, right? Because we're going 4 to the right and 6 down here. So this is going to be the 0.1, comma 3 here. So note that in this situation, when the ratio is 1 to 2, we end up with the 0.13. Now, of course, if you're a big fan of the formula here, you can always go ahead and do the formula here again. So we're going to go ahead and write out the formula here. Now, again, we can see our formula something like this here. So in this situation, our formula is going to be like this. So you have QX1 plus PX2 all over P plus Q. And then this is going to be QY1 plus PY2 all over P plus Q here. Note in this situation, P to Q is going to be 1 to 2 here. So PQ, so this is going to be P and this is going to be Q here. And then we have X1, Y1, X2, Y2. It's going to be something like this. So everything really, you have to make sure that everything's in the proper order here. So X1, Y1 is going to be this here. So that's a -3. So let's go ahead and plug this in. It's going to be 2. X1 is -3 plus P, in this case, is 1 times X2, which is 9. All over P plus Q, so P plus Q is 1 plus 2 here. The same is going to occur here. So Q, which is 2, times Y1, which is 9, plus, in this case, again, P is 1 times Y2, which is -9, all over, again, 1 plus 2 here. So you can see now we can put this together. So let's see, that's a -6 plus 9 over 3. This is going to be 18 minus 9 over 3. So that's going to be 3 over 3, and this is going to be 9 over 3, which again will yield you 1, 3. That's nice. If you like messy formulas, by all means use this here. Now you can do the same thing for QS to SR here. We know that that's going to be the situation here. Notice that we have a 5 to 7 ratio here, because now we're going to be looking at a 5 to 7 ratio. So that means it's going to be 12 parts here. So horizontally, we know our horizontal is going to be 12 parts, so 12 over 12 is just 1, so 1 portion to the right. So each step is, so we can think of it as steps. Each horizontal step is going to be 1. The vertical steps is going to be 18 over 12, which in this case is 3/2 here. Okay, so now we can go ahead and do this here. Because we know QS to SR back here is 5 to 7 now. Now we have to travel 5 steps. We're going to travel 5 steps right, 5 steps down. So that means it's going to be so our location S is going to be at -3. Now we're going to travel 5 steps to the right, which is 5 times 1. And now we're going to travel 5 steps down, which is going to be from 9 and then 5 times 3 halves here. But again, note, I apologize, I'm sorry, we're stepping downwards, so that should be a minus sign here. So it's negative 3 plus 5, comma 9 minus 15 halves. So there's going to be 2, and then 9 minus 15 halves. 9 is just 18 halves. 18 halves minus 15 halves is 3 halves here. So we end up with 2 comma 3 halves, and that's going to be what happens when we're in a 5 to 7 ratio here, right? So again, we want to set that up. We want to make sure that we're in this sort of good thing here, okay? Now, in much the same way, we can do this for number 3 here. So we're going to find the coordinates of f. Now note that pf is 3/8 of pq here. So again, if you remember what we just did here, it shouldn't be too hard to note what's going on. So again, p is x1, y1. Q is x2, y2 here. And again, we have pf here is 3/8 of pq. So that means this is going to be in a 3 to 5 ratio. So you can go ahead and use the formula here, or you can think of it the same way we did before, what we just did here. So again, we're going to have our steps. So in this case, we're going to be looking at our steps here. So 3 to 5 is going to be 8 steps here. Okay. So in this situation, our horizontal step is going to be, well, let's see. Each step is going to be 1/8 of the horizontal distance, which is x2 minus x1. And the vertical distance is going to be, in this case, again, 1/8 of y2 minus y1 here. Okay? So in this situation, now we can go ahead and set this up here. Or again, you can use the formula. Nothing wrong with that. So that means our location here, f, is going to be, we're going to be at x1. And then we're going to add 3 steps here. So it's going to be 3/8 of x2 minus x1. And then the same is going to occur here. We're going to be at y1, and we're going to add 3/8 of y2 minus y1. Now, I suppose one thing I should have done here is I should have mentioned that y1 was also less than y2 as well. That would have made it so that we have a sloping upward here. If it slopes downward, you just basically swap the signs. So now we can go ahead and set this up here. There's going to be x1 plus 3x2 over 8 minus 3/8 x1. Oops. And then this is going to be the same thing, y1 plus 3/8 y2 minus 3/8 y1 here. And note that in this situation, we have a full x1 minus 3/8 of it. That yields us 5/8. So it's going to be 5/8 x1 plus 3/8 x2. And the same is going to occur here. We have a y1 here minus 3/8. So it's again 5/8. So it's going to be 5/8 y1 plus 3/8 y2. And we know that this is the case here. Note also, you could have also very easily verified this using the formula, which we did up there, or you could have verified this using midpoints, and that also works as well. You should end up with this here.